All right. So in the last class, we did learn about dates and time, classes, and manipulations. So I hope everyone has had a chance to work with it since the slides were already out. It was in the session 2 slides. So and today I will send the rest of session 3 slides as well as the recording once it's uploaded. So today we are going to learn about a very important data structure and concept in R programming, which is matrices. And if time permits, we will cover data frames. Personally, I would like to put them in separate sessions because just the nature of these data structures, you'll have to think over it and work through it before you get a grasp of it. Because one of the so vectors are obviously important in our programming, but matrices and data frames are more of practical use. Like every data set you get once you start working in R, you will encounter data structures or files, input files in a form of a spreadsheet. So a more practical approach to data structures is a matrix or a data frame. So hopefully we will cover both of these in today's class. And I want you to keep your RStudio open because we will work through some of the matrices, and working through when you're actually learning it is really, really important, at least for today's class. So I want you to just open your RStudios and have a fresh a script or just the console open. All right. So today, as previously in the last two sessions, we did learn about vectors and how to create these, how to manipulate vectors, how to assign change values within the vectors, and a lot of other vector operations, just assignment operations and addition, subtraction, division, multiplication with vectors. So vectors are essentially they are a single row of a they are displayed as a single row of a spreadsheet. If you imagine a spreadsheet, it a vector is something which where the values are displayed as one single row, and so they're just a string of values, and and so dimensionality wise we can think of vectors as one dimensional because they have only the row dimension. But practically you will want to work with data sets such as the empty cars data set. Empty cars data set, if you remember, it is several rows and columns. So you will look at data in a table format or in an Excel spreadsheet like format, which is two dimensions. So it has rows as well as the columns. So in R, you will with the data structures dealing with rows and columns will be two types. So one is the matrix and the other is the data frame. So we will cover the matrix first. So just to give you a background about what these are, if you think of a vector as a one-dimensional array, an array is just a single data type, values with a single data type. Either everything is numeric or everything is character, or a string. So all the values within one particular vector are the same. Either they're numeric or everything is a character or any other data types or logical. So one-dimensional array is a vector, and the second one that I spoke to you about is the two-dimensional array. A two-dimensional array can be called a matrix, or in R there is another format where you can put a matrix in. It's a data frame, and I'll come to the differences between the two and which you should use in what situations. and you know the uses of each of these data types. So both are pretty handy, both are pretty useful, but there are differences between the two, and you might at times you might want to prefer one over the other. So we'll go into details about the matrix first. Or so there is another. So once you start getting deeper into R programming, you will have to deal with more complex data sets, not just the one-dimensional and two-dimensional. You may have to go into more dimensions, and such more dimensions, three or more dimensions array, or is starting to look like a cube. Or if you start imagining it, it's starting to look like a cube where you have the rows, columns, and then each element will have maybe another row, or another more complexes. Each element in the matrix will have a totally different new list, or something like that. So it's more and more complicated programming, and which you will be using in future. So it's good to get the basics right first. All right, so let's just dive into how to create a matrix. So a matrix is a two-dimensional array, as I just told you. We have rows and columns. So let's create our first matrix. So once, can you just pull out your RStudio and work with me on this, because matrices and data frames are the most practically used R data structures. So you might want to practice that right now. So the way to create a matrix, like any other R programming, within R programming, I told you most of them operate as functions. And so for a matrix, you'll have to use a function called matrix and open the brackets. And within this function, what parameters will it take? So you could give it a range of numbers. So for the very first parameter the matrix method takes is the values that go into it. So let's just give 1 to 12. So that's the sequence of values that go into the matrix, right? So and then so how does a matrix look? It has a few rows and a few columns, right? So if you look at the information that it's giving here on the bottom, in the yellow box, it says the first one is the actual values that go into it. And a matrix has a lot of other parameters. As I told you previously, if you are unsure about what they are, type in the help and see what parameters they have. So if you look at my help box over here, I have the data, which is, they just wrote it as NA, which is the default is NA. And n row is the number of rows you want. And n column is the number of columns you want. So let's just use one of these parameters. So n columns. Now we have 12 values, right? A sequence of values 1 to 12 is what we want to put in the matrix. And the number of columns that we want to define, maybe 4 or even 3, you could define anything. So this is the matrix. This is my very first matrix that I created. So if you notice, within this matrix that is created, you will see some numbers in the square brackets on the or to every row and every column. So that so here 1 comma and there's nothing, and then the 2 square brackets. Within the square brackets, it's the 1 comma. So what that means is it's a row. This is the very first row, and this is the second row and the third row, and so on and so forth. And for the columns, you have because every matrix is defined as say if there is a 2 by 2 matrix, you first define the rows and then you define the columns. So of course, that's not any command. That's why it's giving me an error. I'm just explaining to you. But if there are, say, 2 rows and 3 columns, you define it as 2 comma 3. So that the first one is the number of rows. So it is very similar to this format of defining a matrix, that the first number within the square brackets is the number of rows, and the second number is the number of columns. So if you look at these rows, the row numbers over here, you will see that number to the left hand side of the comma, and then you'll see a number for the columns to the right hand side of the comma. So this is the first row, and this is the row number, and the top within the square brackets we have the column number. And one more thing I want you to notice here, in the forming or in creation of a matrix, the inherent default direction R will follow is to put numbers column wise. So if you see the numbers are running from 1, 2, 3 in one column, and then it starts 4, 5, 6, and then the next column takes 7, 8, 9. So by default, R follows by column format. So it starts filling the numbers in the columns column wise. But if you want to change the format, you want to put 1, 2, 3, 4 over here as rows, you have other parameters for it. So you could see in this help window here that there is something called by row parameter. So you could use by row parameter and then put it in a row format. So just use the by row and put it in a row format. True. So now you will see that these values are being filled by the row. So if you notice the difference between this and this, default format R takes is fill the values by the columns 1, 2, 3, 4, 5, 6, and so on. But if you want to change that order, you have to use this by row equals true parameter and fill these within the matrix as row-wise numbers. So I want you to take 1 minute just to try out one of this, create your own matrix and put it in a variable. So right now I'm putting it in a variable called first matrix. Maybe that's on my slide, but that's what I'm going to use. Or you could name it anything you want. And I'm going to create my matrix. So take a minute, create your first matrix in your RStudio. First parameter is the values that you want to put in. So I'm putting in 1 to 12. You could try anything, 1 to 10, or you change the number of columns and just see how your matrix looks. So everyone did that? Created your first matrix? Okay. Okay, good. So there are a lot of operations to manipulate any matrix. So the third one here, str function, I try to say this and emphasize this in every class because it is kind of important and you will want to know the class of every variable. So you could use the string function str, structure function, structure function str to see how the structure looks like. Now we created our first matrix, right? So within our first matrix, I'm going to just check the structure. So that's the str of my first matrix. So what you will see is that it's an integer matrix, and then this is different. This is something that you have not seen before. In most of my previous sessions, what I did was I created a vector, and that's why in a vector you will get a square brackets 1 comma 1. But here it will actually give you the structure of this matrix. So what it's saying is there are 1 to 3 rows and 1 to 4 columns. So there are 3 rows and 4 columns, and it's an integer type. And then these are the values that went into the matrix. So if you remember, R always has this default format of filling the matrix by the column, and it also reads the matrix by the column. So even reading, it does it by the column, and that's why you get it in an order 1, 2, 3, 4, 5. If it reads by row, then you would have gotten like 1, 4, 7, 10, so forth. So even reading a matrix, it does it by column. So that's the default. So our next command that we want to try, this is something, the dim option is very important for a structure like a matrix or a data frame, because it just one command, it gives you the number of rows and the number of columns. So if you use the dim command on this, my very first matrix, you will get 2 numbers. So one is the number of rows, and the next one is the number of columns. So you could also use the length function on my matrix. So what you will get here is the number, or the full number of values within that matrix. So since I have like the values 1 to 12 within the matrix, it's given me the length of the matrix, or the number of values contained within the matrix is 12. So that's some basics about how to create a matrix and how you could see the structure and length of the matrix. So let's dive deeper into more operations for matrices. So one way you could create a matrix is by combining 2 vectors. So these are some of the very common commands used in R programming. We use something called rbind and cbind, and let's see both of these now, because these are something which you would use very frequently in your programming, where you want to combine 2 vectors, or you want to combine them row-wise or column-wise, just combining 2 vectors. So here in this example, what I'm doing is I'm creating my first vector with some values in it, and my second vector with some more values in it. And then I use this command called rbind. Rbind stands for combine it by row. So put these 2 vectors, stack them on top of the one on top of the other. So that's what it means. Combine them by row. Use the 2 vectors as 2 different rows and put them in a matrix. That's what it means. So rbind is combined by the row. So when I give rbind, you have to give it parameters, right? So you could give it any number of parameters. So what I've given here in this example is I have given my very first vector and my second vector, just asking them to asking R to use the rbind function and combine it by the row. So if you see the output from this rbind function, it combines both of these vectors into a matrix. Since both of these vectors have their own names, right now it's not giving a number to the row. It's actually calling it by the name of the vector. But since there are no numbers to the columns, it's by default given the matrix type of a numbering to the columns. So let's just try the rbind function once again, and I want everybody to try. Just name it anything, first vector, and have any values, and anything that you want, maybe 5 values or 10 values or whatever. And I have my second vector, and I hope you still remember what C stands for. It's just combine, and that's the way you create a vector. So I have two vectors here. The first one 1 to 5, second one 5 to 9 values. So the way I combine it is by right now I'm using rbind function and pass it the name of my first vector and the name of my second vector. So it's created a matrix which has these two rows, and the rows also have their names. The names are the same as the vectors, and the columns are numbered the typical default way of naming the columns. So our next important function is cbind. So as you might have guessed, rbind is combined by the row and cbind is combined by the column. In this example, there's a lot going on. So let me just take a second to explain what we are trying to do, and let's just replicate what we have done with rbind. Let's just use the cbind function and see how these vectors combine. So I'm using the cbind function, passing it my two vectors, vector 1 and 2, and as you might have expected, the names of the columns now are the names of the vectors, and the rows are named by the default naming pattern of matrix. And then these are each vector is used as one column, and so it's combined column wise. So you can combine so what I'm trying to do now is making a matrix, combine this vector 1 and 2, making a matrix, calling it matrix 1. So I can combine even two matrices by using the cbind or rbind function. So in my matrix 1 right now has these two vectors, and this is my matrix 1. And let me create another matrix, or let me use this matrix. So my first matrix has two more columns, and it has the values 1 to 10. Now if I want to combine these two matrices, I can still use a cbind function to do that. So I'm using matrix 1 and using the cbind function using matrix 1 and 2. So right now what I have is I combined both of these matrices. So similarly, you could do combination of any number of matrices, or add a vector to an already pre-existing matrix. So what's going on in this example is using 1 to 3 numbers and 4 to 6 numbers. So these two, it's treating it as two vectors. One has 1, 2, 3 values, and the other has 4, 5, 6 values. And the third parameter I passed it is a matrix. It's a matrix having 7 to 12 values in two columns. So what I just showed you in this example here, by putting it in different variables. So I have two vectors, I put it in different variables, and then I have created a matrix and put it in the first matrix, and then I'm combining these two. If you want to do it, replicate the same thing as shown in the slide, you could do cbind 1 to 5, again, which is the same as the first vector 1, since it has 1 to 5 values, and then the next is 5 to 9, and then that's the same as vector 2, and then put this the same thing as this matrix, put this over here. So it's the same thing that that we did over here, but the only difference is here the column names are the vector names, but here since we did not give the vector names, it's going to take the values, combine it, and put it in one matrix. So any questions so far? Is everybody with me? Okay, so all right. So the next what we want to see is how to retrieve particular values from this vector, and what nomenclature do you use to retrieve maybe a part of the vector, a part of the matrix, or rows of the matrix and columns of the matrix. It is simple, but since we are doing it for the first time, I would like to go in detail about how to retrieve these values. So here, the very first example is the same. Is it's starting with my first matrix, and then what we have is how if you use the square brackets. If you remember any matrix notation, you could use the square brackets to retrieve the values. So whatever you give to the left of the comma is the rows that you want to retrieve, and whatever you give to the right of the comma within the square brackets is the number of columns you want to retrieve, right? So what it's saying in this very first example is I'm trying to retrieve the first two rows and the first two columns from this matrix. So just the first two rows, it's not going to retrieve the entire row, but it's going to retrieve the first two rows and the first two and sorry, not the first two, just the 2 and 3 columns. So it's going to retrieve this part of the matrix, which is the first row, second column, the first row, third column, the second row, second column, the second row, and the third column. That's what it's going to do. So even before going into this, let me just show you some of the very simple ways you can retrieve matrices. So within what do I have in my first matrix? Okay, so this is what I have in my first matrix. So if I want to retrieve, say, the very first value, the very first value falls in the first row and the first column, right? So that's the very first value, 1. So if I give the first row and the first column within the square brackets, it's going to retrieve 1. And similarly, I could do maybe the first row and fifth column, or there is no fifth column, sorry, fifth row and first column. So it's going to retrieve this number, fifth row and the first column. So similarly, you could give it a range, and that's what the example in my slide is doing. You could give it a range and say 1 to 5 rows and first column. So it's going to give all the values from all these rows and the first column. And instead of giving this, an easier way to retrieve an entire row or an entire column is to just leave the columns. If you just don't specify a value for the column, it's going to consider all the columns. So if I give it just the first row, I gave it the first row and all the columns, right? So it's going to retrieve the entire first row. And similarly, I could do the same thing for the columns. I could leave the row space empty, and I could just say, just retrieve the first column. So that's what it's going to do, retrieve the entire first column. Or I could use the second column. So it's going to retrieve the entire second column. So wherever you want the entire one, just don't specify that. So leave that space empty. So if you do 1 comma, nothing, then it's going to retrieve all the columns of that particular row. If you give nothing comma a number of column, then it's going to retrieve the entire column, all the rows of that particular column. So in my slide, this example is to retrieve a part of the matrix, right? So here I want two specific rows and two specific columns. So if you map this piece, if you map the 1 to 2 rows and 2 to 3 columns, then that's the matrix. 4, 5, 7, and 8 is my matrix, and that's what it retrieved. So, and this example talks about using a sequence of rows. So if you want to retrieve more than one row, you use this colon sign. You use 2 and 3 rows, and you leave the columns empty because I want all the columns. So another way of retrieving the matrices is using a negative sign in front of the columns. So if you use a negative sign in front of the row number or column number, it means that you don't want that column. You drop that column. You don't want it. So in my example, let's just print the first matrix once again. Say if I don't want the third row, right? So what I'm going to do is I don't want third row. So I'm giving a -3. So now it's going to remove the third row. So this is gone. This 3 and 8 are gone. So it's going to print the 1, 2, 4, and 5 rows. So that's what it did here. So similarly for the column, you could use, I don't want the first column, I want only the second column. You could do that. Or if you don't want one particular value, that's what this example is showing here. If you don't want one particular value, here what it's showing is I don't want the second row third column value. So what is the second row third column value here? This is the second row and this is the third column. So 8. 8 is the value I don't want to print. So is that right? Let's see. Oh, I'm sorry. So it doesn't want the second row and it doesn't want the entire second row and the entire third column. I'm sorry. So it wouldn't give me, it will take off this entire second row and the third column. So the rest of the values it's going to print. So 1, 2, 1, 4, or 1, 3, because we don't want the second row, and then it's going to print 4 because we don't want the second row. So 4, 6. We don't want the third column, so 10 and 12. That's what it's going to print. So getting rid of one single value within the matrix is a little more complicated programming. And usually we don't do that. Usually we will not use the entire columns or entire rows. But to get rid of one particular value is a little more complicated, and this is my method. But you could very well find some other easier methods, or this is generally what we use in our programming to get rid of one particular single value. So if we start with this matrix, so this is my full matrix has 3 rows, 4 columns. So what I'm doing, suppose if I want to get rid of one single value, which is 8, maybe. So remember that within our reading of any matrix is column wise, right? So 1 is the first value. This is if you think of an index that's attached to each of these values, then 1 is the first value, 2 is the second value, 3 is the third value, and so on within the matrix. Within this matrix. So what you do if you want to get rid of maybe 8, and the position of that 8 is also 8 since the values are in a sequence, right? The position of 8 and the index attached to 8 is also 8. If you think about the way R is reading these values, 1, 2, 3, and so on column wise, 8 is the 8th value within the matrix. So there's one way to do this is you have to first count the whole all the rows in the column. So let me just deviate from this, from extracting the values here a little bit. So you can count the number of rows in any matrix by using this function nrow, or there is another way of doing it. If you remember, dim of any matrix gives you the rows and the number of columns, right? So if you say I want just the rows, then you could within the square brackets you could give the very first value, which is going to give you the number of rows, or you could use the nrow function and it's going to give you the number of rows. So there are two ways of doing getting the number of rows, which is an nrow and dim. So let's go back to extracting our values. So we have to count the number of rows, and then how many values do you want to get rid of? You want to get rid of these. Sorry, if you want to go to 8, you will have to pass all these values, right? So it's 2 columns full of values, and then the position of the 8 is next, another 2 positions you have to go. So if you do the number of rows times the number of columns you want to pass, so that's number of rows times 2 columns, and then add 2 positions to get to that particular value. So you added 2 more positions and then you get to 8, right? And so what I did in this next step is I used the nrows, put it in nr, a variable called nr, used that nr. So what does nrow have over here? Nrow has 3, right? So 3, I use that 3 times 2, that is the number of columns of values that I have to pass to get to my value 8. So I have to pass through 2 full columns. So I do a times 2, and then to get to this position I have to add 2 more. So I added plus 2 to get to this position. So I have this position in my variable id. So what I do is remember, I don't want to have 8 in my matrix or in my sequence of values, right? So what I do is I give it a negative sign and use that index in my matrix within the square brackets. So what it prints out is a list of all these values within the matrix without that specified value, which is 8. So in my result, I don't have 8. So this is a slightly more complicated way of doing. Mostly, practically, you will not need to extract one particular value as such. Yes. So if you want to replace, so I have a question. I have a suggestion here. So if you want to replace or remove just one value in the matrix, then you could use that particular matrix and name it NA. That's correct. But what I want to achieve here is I don't want certain values in my matrix and I want to print out all the other values. So it's totally removing. If you put NA, which is not applicable in a matrix, it's going to print 8 as NA. So I don't want that NA. You could use another step. Of course, that's a good suggestion. You could use another step and remove NA. If you remember from the very first class, we have a parameter called RMNA. So you could remove NA and use the second step, but replacing a particular value with NA might not be desirable in particular situations because it's a matrix and it's going to treat everything as numbers. So I'm going to come to that, the difference between matrices and data frames, in just a few minutes. But everything okay till here? So yes, so another question that I have here is, if we remove one value from a matrix completely, then the number of rows and columns will not match. Correct. The number of rows, and to maintain the structure of the matrix, we have to, as you said, we have to replace the value with with maybe an A or a zero if that is desirable. But if in my previous example, if you see, we are retrieving a vector. So I just want to extract these values and essentially not want to maintain the form of a matrix. So that's why you see that this retrieved value is no longer in a matrix format. It's just the list of values within the matrix without one particular value. Okay. So another question is, you're getting an error if you try to create a matrix with say 19 values, correct? So with 19 values, so usually what happens is in a matrix, will want to have it as an even number because usually it takes a form of rows and columns, right? So if you take the numbers fitting within a matrix in the form of rows and columns, you cannot leave a matrix empty without specifying one value. So 19 values trying to put that in a matrix will not work. You'll have to use an even number. Then it will adjust to the number of rows and columns. And I'm sure you will have to specify, like, the number of columns or the number of rows you want. So that way you'll have to put a even number of numbers in a matrix. So to use something like even value or number, and so to that question, I think, so that reminds me of something. So matrices are not a very flexible tool to use if you have like missing values or different types of values, right? So we'll come to that in just some time, but let's finish this part of replacing values in a matrix. So as you rightly suggested, Dr. Priyatham, that you could replace one particular value in a matrix by using this format of retrieving matrices, of retrieving values in a matrices and assigning it to some other value. So what we are trying to do here in this matrix is we want to replace the value which falls in third row and second column. So where is my first matrix? Yeah, my first matrix is here. So third row and second column, I want to replace this value 6 with a 4. So what I do is go to that particular value, which is third row, second column, replace the 6, assign it to 4. And if you try to print that matrix, you will no longer see the 6, you will see a 4. And similarly, you could replace some values within the matrix by using the full row numbers. So you could suppose if I want to replace my whole second row with 1 and 3. So what R does is, if you provide it 1 or 2 values and there are like 4 or 5 values to replace, it's going to repeat this whatever values you have given until the end of that row. So what I'm trying to do here is I'm trying to replace the second row with 1 and 3. So it's going to replace my whole second row was what, 2, 5, 8, 11, right? So I'm trying to replace it with 1 and 3. So it replaces the whole second row with 1 and 3. It repeats it until the end of that row. And similarly, if you want to replace a part of the matrix, remember in my previous slides, if you want to retrieve a part of the matrix, you do it this way, which is you give it a range of rows and a range of columns, right? And that will get to this particular part of the matrix. And if you want to replace that particular part of the matrix, you'll still have to retrieve that particular matrix, part of the matrix with a sequence of rows and values and columns. So let's see here. So that's what I did. I used the very first two rows and the 3 and 4 columns. So that's going to be 4, 5, 7, 8, and replace that with that sub matrix with these values, which is 8, 4, 8, 4, 2, 1. So where is that? So that's 1, 2, rows 1 and 2, and 3 and 4 columns. Sorry, this part of the submatrix. So it's going to replace, put it in a column-wise order. If you remember, reading and writing will be in the column first order. So it's going to put 8 here, 4 here, 2, and 1. Any questions so far? All right, so let's go get into the arithmetic with arithmetic operations using matrices. So this type of matrix arithmetic and matrix, matrix multiplication, arithmetic addition, or any operations with matrices is important for areas like machine learning and modeling, like linear modeling and statistical modeling. So just quickly to go over the arithmetic operations. If this is your first matrix and I want to add a number 4 to every one of these values, I just do a +4. So it's going to add a number 4 to each of these values. And if I want to add two matrices, if you remember your matrix arithmetic from maybe 10th standard, you will have to make a matrix with the same number of rows and columns for addition. So in R, if you have to have the same number of rows, if you don't have the same number of rows, then it's going to error out. I didn't try that, but you could try and see. If you don't have the same number of rows and you're trying to add two matrices, it's going to give it an error. But if you have the same number of rows, you could still have 3 rows, and if you have only one column, then it's going to add that column to every one of these columns in these matrices, in this matrix and the first matrix. So what I'm trying to do here is adding two matrices. First, I make a first matrix with 1 to 12 on values in it, and a second matrix with 1 to 3 and have like 3 rows and 4 columns. So this is my second matrix, and I have 1 in my first column, 2 in my second column, and 3 in my third column. So if I try to add the first and second matrix, since both of these matrices have 3 columns and 3 rows and 4 columns, it's going to overlap the values exactly and add them. So this is not a problem. Since both of these have the same dimensions of the matrix, it's not a problem. So you could, instead of doing this, creating a second matrix, what you could do is you could just say add 1, 2, 3 as a sequence, as I just told you. Now 1, 2, 3 is just 3 values which it considers as rows. So it will add 1, 2, 3 to every column over here. It's going to add 1 to the first value, 2 to the second value, 3 to the third value, and goes to the next column, adds 1 to the first value, 2 to the second value, and 3 to the third value, and so on. So that's about matrix operations, and you have some other methods as row sums, which is a more convenient way to obtain the sum of rows within the columns. Row means to get the mean value for each row, and you have similarly you have column sums and column means. And this is something important for machine learning field, where you transpose a matrix. So you flip the columns around. Suppose, what's in my first matrix? So my first matrix, I have columns as 1 to 5 and 6 to 10, right? So I use this function called T, which stands for transpose, and put my first matrix within that T. So it's going to flip my columns to rows, and yeah, my two columns to rows. That's what it's going to do. Transpose of a matrix. And this is more for inner product of two matrices, which is more for more complicated mathematical operations. But for now, we just skip this part and go into data frames. So as matrices, as you saw, matrices are more important if you have uniform data type throughout your matrices. Suppose if you have only numbers, or only decimals, or something like that, with it throughout your data. If you have just numbers, then a matrix is more important. A matrix is more useful. But if you have more than one data type, suppose if you have, for example, I put an example here, like names of employees, the first name, last name. You have salaries, which have to be numbers, names, which have to be characters, and dates, which has to be like the date class, as date, as we saw in a previous session. So if we have to combine these different data types into one data structure, then that's what a data frame is used for. So in a matrix, right? In a matrix, all data has to be of the same type. If you try to put numbers, add numbers and characters into a matrix, it's going to convert it into one or the other. It's going to make every character as a number, and it's going to similarly, whatever the first column is, it's going to convert every other type into the column type of the first column. That's for a matrix. But within a data structure, within a data frame, you can have multiple data types. So let's just dive into creating our first data frame. So the way I have here is I'm using the same way that we used vector 1 and vector 2 to make a matrix. So similarly, we use the rbind function to join two vectors and put them into a data frame. So this is, we'll use the same example, although I have a different example on my slides. We'll use the same vector 1 and vector 2 to put them into a data frame. So I have this. So remember, if we want to make a matrix out of this, we have to use a matrix function, right? So that's a matrix. And let's see what. If we want to do a data frame, you have a function called as.data.frame. So as.data.frame puts these vectors into a data frame. So what's the, let's just 1 second. I don't know what happened to my vector 2. Oh, I think I omitted some row names previously. So anyway, so what I want to tell you here is in this method, we have our as.data frame. If you remember from our very first classes, if you want to convert any of data types to any other, we use as numeric, as.numeric, as.character, as.integer. So using as dot something is is pretty convenient, and it follows the pattern for most of these data types within R. So we could use as.dataframe to create a data frame from any two vectors. So the example I have here is by using an R bind of these two, and by using R bind of these two and creating a matrix, right? So the one thing that I omitted in this example, and due to which it's giving me an error, is the R bind. So I'm going to just add this. So I have a question here saying data.frame, and it worked. So somebody used instead of as.dataframe, you could use he just used data.frame, and it worked. So both are synergetic functions. So as.dataframe and a data frame. So I don't know the subtle difference. The subtle difference between using as or not. I might get back to you about the difference between that, as using as or just a data frame. So let's continue with this example. So what I have here within the function is I'm doing an R bind with these two vectors and then using it as a data frame. So you could simply use data frame as one of the person suggested. So you could simply use data frame. So I think there is a difference between the two because the names of the columns did change, but I'll get back to you regarding the difference between using as or just using a simple data frame. So within the using a data frame, right? So if you remember in our first class, we tried the empty cars data set, and you could retrieve every one of these variables using a dollar sign. You could retrieve every one of these columns using a dollar sign. So that's the purpose and benefit of using data frames. If you quickly want to access any of these columns using a dollar sign, putting it in a data frame is much more convenient, and you could have different data types. Of course, that is the very first benefit, having clubbing different data types into one structure within a data frame. So I have certain examples here, similarly the same pattern that you would follow for using it for creating a matrix. So you combine these two vectors using an R bind and then use an as data frame to convert it into a data frame. And if you use the structure of for a data frame, you will see that it starts with data frame. It says the class of that structure is a data frame. It has six observations and two variables, and it lists each of these columns starting with a dollar sign. So that's the column name, dollar, and the column name and whatever values it has. So if you have more values, it's just going to give a dot dot dot, but it's going to list maybe first 6 to 10. I don't quite remember, 6 to 10, I suppose. And you could use the nrow function. So most of the functions that work on matrices also work on data frames, like the nrow function, the length function, and also the row sums, column sums function. So you could try that for a data frame setting and see how it goes. So this is another way of creating data frames, because in the previous slide, we had just the numeric vectors and combining them to form a data frame. So in this slide, in this example, what we are using is we have different types of data. We have employee name, we have salary, and we also have start date of the employees, which is a date class. So if you want to combine these three, put it in a data frame. So you just combine the three, put it in a data frame, and if you use the structure symbol, you use the structure symbol, you get whatever types it has too. So if you see, each of these is a different type. So for the employee, it's a factor with 3 levels. It's for the salary, it's a numeric, and for the date, it's a date class. And so that's giving formats. So since you have more than one, it's going to display just the first two. I think it has a number of characters to display, and then it's going to give a dot dot dot. So it's just to look at the structure of the data frame. So similarly, what you can do, you have something called names method function. I think this one we did look at it for the empty cars data set. We tried to look at what different columns there are. You could use the names function to get the names of every column. And if you want to replace any of these names of these columns to something else, you could actually retrieve one particular name from the names of these column names and replace it. So similarly, you could set the names for each row within these data frames. So try this slide. Work with matrices, work with data frames. Two obviously very important for most of your practical work in R. And that's pretty much the class. I think we did cover most of what we had planned to for matrices and data frames. So any questions so far? So I will get back to you with the difference between the two as and using simply a data frame. And usually when we want to convert something to a particular data type, whether if you want to convert an already existing a vector to a matrix, we use as dot matrix, as dot data frame. But I will look at the subtle differences between the two and let you know in the next class. And also I will update, I will send you these slides, and the recording is in the process of uploading. So I will send you a link to session 3 as well as today's session. And I should do a better job in keeping the names of the files, the slides, conform to whatever session it is. And I will, initially I had planned to finish it in the 3rd session. So that's why I have it as session 3. So any questions so far, everyone? So there is a suggestion from one of our members. So he says, why not just use data frames for all purposes, as matrices collapse when we remove or add values? So true. So one advantage of having a matrix is just the ease of retrieving the values or retrieving one particular values within the matrix using the numbering system of the matrix, using the square brackets. So that advantage is not there in data frames. So each of them have their own advantages and disadvantages anyway. But matrices, the way you could transform a matrix or transpose a matrix or do those inner product and arithmetic is not possible with data frames. You'll have to. I think it is possible, but it's a much more complicated way of doing it, because you'll have to transform everything into one particular data type. So there is another suggestion which says R operates faster on matrix. Is that true? Yes, because matrix is one particular data type, and since it does not have to convert into another data type to do any operations, it does operate faster on matrix. But it's not the difference is not something that a visual eye can see, at least for most of our programming. It is the difference between using a data frame and a matrix. You will not see the speed difference practically unless it's unless you are operating with very huge data files. Any other questions? So as and when you keep going through these sessions, you will know that you will prefer one over the other. I personally like matrices because I work with a lot of just numeric data, and mostly I don't have to like store character variables or within my data. So for mostly for like simulations or anything like that, where you have all numeric data, you will want to use a matrix instead of a data frame. And but you will as you progress through these sessions, you will form a liking towards more of a data frame, because it has this flexibility of storing all these data types, and it looks more like a spreadsheet that most of us are used to. So any other questions, guys? If not, I will send out these slides and recording, and we will have our next class on Tuesday Tuesday evening. So Tuesday night, actually, EST 8:30. Is that okay for everyone?